In the previous tutorial, we've built a new tile. We've created a new prefab out of that tile and then used this tile to load in our game from the textual specification of our level. And this is the result. In this tutorial, we will build a new tile, a player tile, and we'll build a very simple character controller around it. Okay, so let's start. We create an empty tile, empty game object. We name it player. And just like in the previous one, we'll create an empty child and in which we'll maintain the sprite. For this purpose, I have already downloaded a sprite sheet, which I will be using, and that's the sprite I'll be using is Mario sprite. In a later video, I will show you how to cut the sprite sheet, so how to cut the structure like this into separate tiles and then create the specific animations. But for now, I will just use my Mario. So I'll go into the sprite, I'll add a sprite render, and I'll add Mario in there, right? And there is it, there is my Mario. Great. Next thing I need is a, so in the top, in the parent, I'll add a new rigid body. So I will have Mario to be a physical object to save us a lot of programming. So I'll be using gravity and velocity and stuff like that to move Mario around. So when I and a couple of parameters will set. I'll set interpolate to interpolate, and we'll freeze the rotation according to z-axis. That means that the Mario will never fall into the depth. Right. So when I run this, Mario will be attracted by gravity and unfortunately fall through the walls. The reason is quite simple. I haven't added any collider on Mario, so I add a new box collider for Mario. So when I run this, Mario will collide with the level and then no longer will fall onto the ground, underground, right? Next thing I'll do, the box collider tends to be quite problematic because sometimes Mario, for example, when he's walking uphill, tends to get stuck because of these very sharp corners. So I will actually use two different colliders. So I'll put this one a little bit up. Oh, I have to turn off the game. So I will put this one a little bit up and sorry, like this, and a bit like this. All right, so that's about right. This box will be used mostly to detect collision with enemies, and I will use a circle collider for feet. All right, I'll make this a bit smaller, and then I'll put it like where the feet are. Right. So the bottom collider is for detection of the ground, and then this one is usually for enemies. Right. When I run this, the Mario should still detect the ground correctly and not fall through. All right. The next step, what we're going to do is we're going to build a simple controller for Mario. We'll let Mario move left and right according to x and y axis. So we'll add a new script on Mario. We'll name it player controller. And what we'll do is we'll copy this script, which is now in the parent folder. We'll copy it into our scripts folder. Right. All right. When we open this script, what we will do What I'll do is that I'll type the script in the background so you guys won't see me making 2 million mistakes, and then I'll just discuss the changes I made in the script. Okay, and here it is. The script is quite simple. First we set the maximum speed which we want the player to move. Then we get the reference to the rigid body of the player, so to the physical component of the player. And we get the reference to it when the script is started. Currently we don't use update function, we will use it a bit later. What we do use now is a fixed update function. Fixed update is an update that is happening when physics are updated, and which is not exactly every single frame, right? So there's a fixed period between fixed updates, so we can compute physics appropriately. In here we get the horizontal axis, so that means checking which arrow the user pressed, and we're using this cross-platform input manager from standard assets so that we can easily port our game to mobiles, mobile phones and other devices. And then we call our move function. In the move function we accept one simple parameter called move, which gives us the number between -1 and 1 depending what arrow was pressed. If I press left arrow I get the value between -1 and 0. If I press right arrow I get a value between 0 and 1. This value between 0 and 1 or 0 minus 1 depends on how long am I pressing the arrow. If I just tap the arrow I get a small number. If I keep pressing the arrow I get a higher number, right? Next, what I'll do, I add a velocity to my physical object, which is that value that I've received from the keyboard multiplied by the maximum speed, and I maintain the velocity according to the y coordinate. The next thing what I do is I will automatically flip the Mario to face the direction towards which I'm moving. Just to give you an idea what I'm actually trying to accomplish is that, you know, if I have Mario moving left and right with the keys, you know, Mario would be either moving right or backing, you know, going backwards. So what I'll use this little trick in which I use the local scale according to the x coordinate. And look, if I flip the Mario according to -1 and 1, I get Mario facing towards left or towards right. Right? So I get -1, 1. Simple as that. While we're here, let me do one more thing which we forgot, and that is I'm going to tag Mario as a player, right? So that means that our camera follow script can use Mario. So I go to my main camera and I add a smooth follow 2D script, which is used by our level manager component, which automatically adds the target to follow Mario. Okay. So going back to player controller, basically this piece of code detects if I'm moving to the right, I make sure that Mario's local scale is 1, that means facing right. But if I'm moving to the left, I'll flip Mario's direction. Alright. So let's save all this, and so we go file save, and now we save the scene, Mario tutorial, and let's hit the play button and see what we've done. As we see, the camera automatically followed Mario, which we've left on the screen, and we can use left and right arrow to control the Mario. I think the movement of Mario is a bit too fast, so what I can do, I can tweak the parameters while playing the game. So I go to my player and I set maximum speed, for example, to 3, and see what will happen. That's too slow. Let's say about 6, and this is about right. Okay. Please note that when I turn this off, now the maximum speed goes back to 10. So I need to tweak my parameter in here. Now when it's off, set it to 6. Now this Mario is the one that I left there on the screen, right? So that's the one that I've been working with. So that's my working Mario. That's not the one I want. What I want is I will create a prefab out of the Mario, put it into my sprites folder, sorry, into my tiles folder, raw folder. Right, so now I have two tiles, my brick tile and the player tile. So I go to my level manager and I drag and drop player onto the P tile. I disable my working Mario, and when I run this, I should, there we go, there's my Mario. That's exactly the one that as we've specified it in our textual document. Right? So if I open it, we see we specified we have a platform with the Mario standing on the platform and facing the enemy. Great. Now we're going to build a couple new platforms, the ones that will be moving left and right and up and down. So let's just do